Hello everyone and welcome to today's webinar. Today's topic is Black Box KVM Solutions. My name is Bo and I'm a product manager at Convena. Before we start, I would like to run through a few housekeeping rules. Everyone will be muted to ensure a smooth presentation. Feel free to put your questions on the right-hand side in the chat box, and we will read them out to the panelists afterwards. We will also record the webinar. Recording will be shared at the beginning of next week. And I'd like to pass over the word to Sales Director for UK and Nordics. Are you here?
Yes, I am. Thank you very much, Bo. Just to begin with, a massive thank you to the Convena team, as well as Brian Andrews, who's our lead application engineer, and the whole marketing team for putting together these great webinars. And I'm in no doubt that the participants that have attended these webinars have learned a little bit more about Black Box KVM solutions and how you can implement these sort of solutions to your wider customer base. Just a little bit of background is that in Denmark, we really had a look at the sort of different distributors that was available, and I'm so happy to say that we've had a successful partnership with Convena. Convena have provided us with some great services, really helping us to engage better with the resellers. Most importantly is that we can provide better delivery and stock availability due to Convena's slick warehouse process. So we really are excited about this partnership. And I really look forward to seeing some great business coming out of these webinars that we've been hosting. So without further ado, I would like to introduce you to our lead application engineer, Brian Andrews, for our third session, and I'm in no doubt that you will find it informative and productive. Thank you so much again, and over to you, Brian.
Brilliant. Many thanks, Bridget. Welcome, everybody. This is the third session, and we're going to be providing you with a KVM update and the future of KVM as we see it currently. What we're going to do is we're going to look at the concept of unified KVM matrix solutions, and then we're going to have a look at direct connect versus IP. There are two main technologies that are involved within KVM, and currently direct connect makes up the majority of the usage, but IP is obviously beginning to accelerate greatly. There are advantages and disadvantages to each, so we're going to go through some of that. Have a look at the KVM system management tools that are now available, and then finally we'll move on to KVM and audio visual control. So the future of KVM. Now, obviously, everything's up for change as technology moves forward, but currently where we're sitting, as we look forward, what customers are requiring is more user friendliness, less of these 1980s looking menu selection systems that a lot of KVM has employed and a few systems continue to employ. So finding it much more convenient using hotkeys. This has been around for quite some time. Relation of that, moving from hotkeys on a keyboard to actually using a touch screen, setting up and tearing down connections. Customers are also quite excited by glide and switch. This is something that I get asked for all the time. It's something that we go through a lot at the trade events. It's a real customer need these days. And the idea is that you can have selection of screens on your desk, and these screens are all connected to different computer systems through a KVM. You can computer systems themselves are not connected together, don't have any common networking protocol going on behind them that links them. So they're completely disparate systems. But the customers want to be able to use a single mouse and keyboard and to glide the mouse across the desktop as if it's one single extended desktop. No, they're different machines. Makes it very easy for customers to switch between different systems quickly and efficiently. People are looking at multi-viewers, making better use of these large format displays that a lot of us are like seeing around the offices and around all kinds of premises these days. So, you know, once you get to a 50-inch screen plus, you can start putting multiple images onto that screen. So we're going to go through some of that later. But multi-viewers are becoming quite a required environment. User profiles. People want the ability to have a single login that gives them access to the servers that they have authorization to access. And so their user profile can go with them wherever they are in the building. They can log on to any user station and bring up just the servers that they need to look at. So all this together, there's quite a few features and functions that customers are already demanding. There's also the idea of linking sites together across the country or across a campus. So long distance wide area networking or for campus fiber extension are being required quite a lot these days. We're seeing quite a big pickup within this area. IP-based extension systems. Almost everybody runs some form of IP network, and being able to use this existing infrastructure as a way of providing access to the servers does make perfect sense, because most of the hardware is already in place, but there are certain pitfalls which we'll go through a bit later. Now currently, I think that most of us have heard of 4K, and hopefully most of us are using it to one extent or another, whether it be just at home for watching television or whether it's in the office. Certain customer bases require the higher resolutions. With higher resolutions comes a need for higher bandwidth. And as we look forward at 8K being introduced, the need for bandwidth is going to increase fourfold immediately. So we saw when we went from 2K to 4K, the bandwidth requirement is 4 times higher. It's going to be the same again as 8K. And we're going to have to wait to some extent for new compression techniques or improved compression techniques to be able to take 8K efficiently around the network. We're seeing a much greater need for secure KVM, and this is something that I envisage is just going to continue to grow. So the idea of keeping certain information servers that's difficult for people to access without the authorization rights and difficult for people to hack. Secure KVM's becoming quite prevalent. We'll touch on some of that a bit later. One of the big needs that we really are seeing from customers on an almost daily basis now is, can they have the ability to connect virtualized machines to their KVM environment? We've been able to connect virtualized servers, but traditionally what's had to happen is a user gets onto a server, virtualized server through a KVM system, and they then have to log on through the virtualization system to actually get to the server they require. With modern day KVM, we don't need to do this anymore. Basically, if a user wants to get onto virtualized server 4 sitting on a particular hardware platform, we can now pop them straight onto it. And quite often we're using protocols such as RDP or PC over IP. But sometimes we're coming up against end-to-end requirements as well. So we're going to go through some of the advantages of these. Of course, everything's becoming driven these days, and the Internet of Things is just putting more and more to the network. So if we have a look at a typical kind of control room scenario, this is quite a helicopter overview. We've got our infrastructure components on the left-hand side, contained in a cabinet or a group of cabinets or a group of server rooms. Now these are providing the infrastructure to the building via the way of the actual servers and the storage arrays that are being required. And through various network cables, whether they be copper or fiber, and through the use of switching, whether it be direct connect switching or whether it be IP-based switching, we use the actual core infrastructure of the cabling of a building to provide all the connectivity. There's obviously a need for networking components. One of these components is often video walls and also signage systems. Now, both of these, again, is this same infrastructure, the same cabling systems we're using for providing desktop access for email or whatever business systems a company uses. Bringing on board AV. So AV requirements are going up. Meeting rooms, huddle spaces are all beginning to have audiovisual equipment in them to allow collaboration to take place in a much easier method. Bringing all this together, often employ touchscreens to give users a nice, easy method for controlling and sharing different services around the building. And sitting in the middle of all this is network management. And the way we tend to link everything together is via using KVM switching and extension to bring in all these infrastructure components and get the information out to where it needs to be. The video walls, on the signage screens, at the desktop. So traditionally, things have been very much point-to-point or matrix switched using category X cabling systems or fiber cabling systems, but not employing IP. Over the past few years, we've seen IP begin to open up KVM as another method. Rely on the compression techniques used. We talk about direct connect systems, we can basically do whatever we like with the raw cable. We can use whatever signaling techniques we want to employ, and we can make a much fuller use of the bandwidth capability of the cable. When we move over to IP, things become slightly different because the IP protocol is very established, it's very standard, people understand it in the same way across the world. It becomes a very useful tool. But it does mean we're also at the mercy of an IP packet, which is a bit long and wordy for sending good quality video fast enough around the building. Just to bring one point into this, a TCP/IP packet at the end of it contains a checksum to make sure that the packet's arrived. Should. Pretty useless in a KVM environment, especially with audio visual in high bandwidth requirements, high frame rate requirements, because you haven't got time to ask for a frame to be retransmitted if it was errored. So the IP protocol don't lend itself so well. So we've had to wait until 10 gig networks become far more plausible and installed to a much greater extent before we could really introduce 4K IP. We've been able to do 2K over IP for quite some time, but 4K we've had to wait for the encryption, the encoding techniques, compression techniques to catch up and be useful enough. So with unified KVM, the point is that we're trying to bring these non-IP based products together at the same time with IP networks so that we can actually mix and match different technologies together to provide a more unified solution for the customer. And this can have great effects of actually protecting the investment that's been made with existing KVM platforms. So customers have already spent quite a good outlay typically on a KVM solution to provide good access throughout a building. And what we can do is let them keep that investment that they've made and add to it, adding on IP technology. Now, the advantages to this are we can begin not just to provide access to physical machines, but also to virtualized machines. And this helps lower the cost of future additions onto the KVM network, allows us to integrate with a much wider range of platforms that are already out there. So it doesn't really matter which vendor a customer has used in the past, have invested a lot of money in a lot of different areas. When we start unifying KVM, we're able to provide a way where they keep their existing system, but can now add to it with an IP platform and give them much greater spread and much better use of their networking. So what we're looking at doing is creating an architecture which basically encompasses IP and virtualization and non-IP altogether. So on the diagram on the right hand side, the top left of the diagram, we can see the DKM. This is a direct connect system. It does not use the IP protocol. On the right hand side, we have Emerald, which is a unified KVM solution, and it runs over, or can run over, an IP network. And what we can do now is add the IP side straight onto the back of the direct connect side. In fact, as we move forward, we find we can actually unify this to an even greater extent when using particular products, so that you can actually run IP and non-IP completely side by side, and they will come under the same management tool. So looking at the picture at the bottom, you can see there's a KVM manager that we employ here. This KVM manager is able to manage not just the non-IP side, but also the IP side as well, and bring everything together under one platform. By doing this, this allows us to diagnose and address potential performance problems before they occur. So we get notification when bandwidth usage is going up, when frames are being dropped from the video, when the connectivity is not as sturdy as it was. So there's a lot of flags and a lot of instantaneous information we now get for these, what have now become mission critical systems. So our first foray into unified KVM is the Emerald system, and it's a world first. The Emerald is able to support IP and non-IP connectivity concurrently. So it's based on a zero client system, so there is no need to add software anywhere onto the KVM solution. It's a hardware-based solution. Even the management system is hardware-based. So it makes it nice and easy to add on to whatever system a customer is currently using. And we can transmit over copper or fiber-based IP. And as I say, we can also just make use of the raw copper or the raw fiber to run direct connect. So within Emerald, we're looking at supporting HD and 4K video resolutions currently. We will look at upping to 8K as soon as time is right. Currently, there are very few screens available, no content, and certainly no content delivery systems that are really running IP outside of laboratory kind of environments. So it's very much in a test phase. You can go into shops and buy an 8K television and it'll upscale 4K beautifully. You'll get a great picture, but the actual real guts of a network, the playout systems, the content, and all the other parts of that, they're not available yet. Emerald will be something that we look to develop further as these become requirements. And using Emerald, we can support both physical and virtualized servers concurrently as well. And if you decide you need to jump onto a virtualized server, we put you straight on to the virtualized server. So from your one single point of contact through the KVM user station on your desk, you're now hopped straight on to whichever data center, whichever rack, whichever virtualized server, whichever storage array that you may need to get onto. It's there at your fingertips. As I say, it's a zero-based client, so there's no software involved. However, we have introduced a remote application which will provide a KVM receiver via software for Windows 10 devices. This is not something to use within the same building. If you're located in the same as the servers, use your actual KVM system. If you're working from home, working abroad, working the other side of the world, remote app is going to allow you to jump onto the servers you need and provide any management or support that you're required to do so through your job. So it's a nice way of offering additional external access onto the unified KVM system. Currently, we've got HD transmitters, got 4K transmitters, and we've got our brand new 0U transmitters, which don't take up any rack space at all. They plug in the back of the servers and basically hang down. They're very, very small. And any Cat-X cable that's required just plugs straight in the back of them. On the desktop, where the user sits, we're providing HD or 4K receivers. And as we get on to moving forward through the roadmap, we'll see that we're going to be able to use the 4K receivers to jump onto whether it be an Emerald 2K device or an Emerald 4K device or an Emerald SE standard edition device. They're all going to be available from the same receiver user station. We've brought out a range of switches to support this. So there's 1 gig, 10 gig and 100 gig switches, and what you need depends on the bandwidth requirements, what you're actually going to be connecting to and squirt through system. We've got a full range of switches available now, so we can build these KVM solutions completely. So got the Boxzilla KVM manager, which not only manages user rights, access rights, integration with Active Directory, etc. It also allows you to add on new units, monitor them, and push out firmware updates as required in a very easy, very manageable method. It's very graphical. It's quite a pretty interface. We'll see it a bit later. But there's a lot of statistical information available for individual link, each individual device, for networks as a whole. So Emerald 4K is a very scalable solution. Basically buy 1 transmitter per server and 1 receiver per user screen. As multi-stream technology comes on board, you can actually use 1 receiver station to control several desk monitors. So this is one of the beauties of one of the up-and-coming technologies of MST. It's been around for some time, but it's not really been implemented, and we're able to make use of this technology so that having a receiver desk set up with 4 screens is not really a problem. We provide pixel perfect 4K video, audio, and transparent USB. That's to USB 2 specifications. provide a very, very, very low latency switching time to hundreds of endpoints. But to do this for 4K, we do require fiber. The bandwidth on copper, we can't really guarantee the bandwidth on copper. Copper interfaces tend to be required just for management side of things. KVM is being utilized through the fiber. So all the video and the USB control is actually fiber based. We use lossless compression techniques. So we don't lose a pixel. Everything that comes in goes out. What the user sees is a pixel perfect image. We can actually adjust this compression in 5 different steps depending on the amount of bandwidth that's available on the network. We utilize DisplayPort 1.2, which is 4K 60, 10-bit color. They are a single head system, but obviously using MST, we can expand on that. They provide network resiliency by the fact that we provide 2 SFP sockets. So you can run 2 lots of fiber, each running at 10 gig, and we can set up resilient networks so that there's no chance of anything dropping off. So allows us to provide target pooling, where you may have a group of common servers and you don't really care which one of these common servers to, just need to get on one of them. So we can pool all these targets together and then connect on to whichever one in a first available technique. End of the bandwidth requirement, Emerald standard edition, sorry, the Emerald SE. Now this provides low latency, incredibly low bandwidth requirement. So we're not looking at running this over a 10 gig fiber. We're running this over 1 gig copper. But for full screen, full motion video, we're only needing 35 megabits. So one of the applications where this is being taken up to quite a great extent is for people working from home. They can put a transmitter station onto their current KVM solution. They take the receiver station home, and even, you know, out of the way locations generally can get at least 35 meg on their broadband connection, and we can then provide them an excellent quality link into their KVM solution. This can also be used across wide area networks and anywhere you have restricted bandwidth, but you want to be able to get a solid usable connection. So we have a lossless compression technique, which is visually lossless. So to the user, everything looks perfect all the time. If you're using particularly critical applications, I don't know, passing X-rays around a building, or passing broadcast quality information or film footage around a building, step it up to pixel perfect mode. We then require 350 megabits per second of bandwidth. So it can be utilized in one or two ways, either ultra low bandwidth, visually lossless, or pixel perfect mode, where it is actually mathematically lossless. Both identical to the user. If you are passing across mission critical video, then it's better to go in a pixel perfect. We provide virtual media access. This is done through sharing by license. Video format of this box is not DisplayPort, it's DVI-D, which makes it eminently compatible with HDMI straight away. And we have DVI-D to VGA, VGA to DVI-D converters that are tiny little things that actually genuinely work, unlike a lot of the products in the marketplace. We can actually use this DVI-D interface in a myriad of. There They're available as a single head or a dual head version, typically supporting single link DVI, so that's up to 1920 by 1200 pixels. And we've also got the 0U transmitters, which are USB powered and require no additional rack space. We've now released Emerald Remote app. So this is a piece of KVM software to run on Windows 10, which also provides an excellent method for remote access. It's not something you'd use on the same campus, because if you can use KVM hardware, you're going to get the response, but the remote app provides the ability to jump onto any Emerald transmitter, do what you need to do from the comfort of your home, from the other side of the world. Basically turns the Windows 10 device into a software receiver. Now, currently it's supporting HD video and USB HID. This is going to be including 4K support later on. So that's something we're very much looking forward to. It also will give you the same virtual access as the other systems, so you can jump onto virtualized servers just as easily as if you had a hardware receiver. With the Emerald system, we have to complement it a range of IP switches. As I say, these are 1, 10 or 100 gig editions, support various form factors, 48 ports, copper, fiber, layer 2 stroke layer 3 switching, and they support all the protocols that we need to run KVM solution efficiently so that we're not wasting bandwidth. They're available with redundant hot swappable power supplies and fans, so that there's no failure that should bring a switch down. Power supply fails, its redundant power supply is already in there providing the power, then just get power supply up and running capacity. Users haven't noticed any drop. It's all good. And there's a wide range of compatible SFPs and SFP Plus modules, depending on the distances that are. So a bit of a product family comparison. Technology all began with Invisa PC, right-hand side of the page. Provided a 1920 by 1200 at 60 Hertz, single or dual head connectivity. It was IP only, had a single RJ45 connector on it, provided transparent USB, assuming the bandwidth was there, what the video was requiring. Video takes priority. It could use RDP or Remote FX to support virtualized devices. Bogzilla, it could be managed or unmanaged. Out of this technology directly came the Emerald SE. So Emerald SE is basically Invisa PC 2. It's a much more powerful platform. Whilst we're supporting the same resolutions and the same number of heads, we're now able to support IP or direct connect. It's still only one RJ45. Put down here that it can use up to 50 megabits per second of bandwidth. Full screen, full motion video. I've never seen a system require more than 35 megabits per second. So it does make excellent use of low bandwidth situations. We've increased we can now support PC over IP. It all can be used in a managed or an unmanaged environment. And the big brother of the SE is the Emerald 4K. This will support not just UHD resolutions, 3840 by 2160. It will actually go up to the professional standard called DCI, something that the broadcast industry use extensively. And that resolution is 4096 by 2160. They tend to use that extra bandwidth for some of the control buttons that are around the outside of the screen. It's IP, and Direct Connect is coming out very shortly. As I've already mentioned, it has 2 SFP sockets in it, SFP plus sockets, to provide access to 10 gig networks. It's transparent USB for keyboard and mouse, and also full USB 2 speeds for 480 megabits per second to the desktop. We've increased the VM support, so RDP, Remote FX, and PCI over IP, now also including host and VM sharing via an IP multicast environment. In the future, it will also be able to provide a very secure cross-network platform as well. All of these products can be managed under one single management platform. That platform is Boxzilla, which we'll cover shortly. So looking at some of the differences between products technically, Visa PC was visually lossless. Emerald SE is visually lossless. Move up to pixel perfect mode if you purchase a license to release that, and the bandwidth requirement goes up full screen motion video 35 megabits per second to 350. 4K units are all pixel perfect all the time. We support audio and serial on all the Emerald series. Switching time is sub 1 second. And you can have an unlimited matrix if you're using Boxzilla. As we can see, we've got multi-head support now. And in both cases, you can basically rack mount the units and have 2 units in 1 U of rack space. So it's an eminently scalable system because you're only buying the hardware as you need it. If you need to add on a new user, you buy a new receiver. To add on a new server, you buy a new transmitter. Nice and simple. Don't have to pay for anything you don't require. No fixed port count at the switch. So you can start off with a very small system. Our smallest switch is an 8-port 10 gig switch for 4K. And build on it from there. Multiple 8-port switches running 100 gig bone. Add users and manage users very easily from central locations, or indeed from anywhere across the network. Boxzilla systems will allow you to manage themselves without that platform. So if you want to start off with a very cost-effective solution, run a few Emeralds or a few Emerald SEs and not worry about a global management. As the system grows and you want to be able to push firmware out across the whole network, easily done. Add on a Boxzilla, one single point of contact, and everything can be upgraded incredibly quickly and easily. So it's very quick to build up proprietary KVM matrix solutions, and if you want to, at a later date, then add IP connectivity into those systems. So this is how also, if a customer has an existing KVM solution, a lot of investment in, it's not going to be written down for quite a number of years, we can add to that using Emerald 4K or Emerald SE to provide IP connectivity as well. So we can basically combine everything together into one system. So here's a typical application example. We can see down on the left-hand side at the top, we've got one of the 0U transmitters. Below that, we've got one of the low bandwidth SE transmitters. And below that, we've got one of the high bandwidth 4K transmitters. We've also got a selection of virtualized servers. Then plugged into this IP network, we've got the Boxzilla management, bringing everything together. So the users on their right-hand side sit at their desks They're able to use their receiver to connect onto any of these systems. And this is where we're now heading to. By the end of this year, be able to use that receiver on your desk to connect to a virtualized server, 4K streaming system, low bandwidth SE, 0U transmitter in exactly the same way. This is what we mean unified KVM, bringing everything together under one single management. So if we have a look at some of the use cases, within broadcast, we're looking at connecting multiple editing suites and the users together. The equipment can now be taken out of the editing suite and put elsewhere in the building. Previous presentations I've done for you guys. And this obviously reduces noise and heat and everything else in the room. But it also allows a much more sensible use of equipment rather than having to go out and Avid platform per editing suite, a film light platform per editing suite. You're never going to use those two systems at the same time. You'll be using one of them or the other. So to have both of them put into the same editing suite doesn't really make sense. It wastes a lot of money. It wastes quite a bit of investment. So by bringing these devices out of the editing suites and putting them into a central location, then using KVM, we basically provide a very cost-effective way, reducing the number of high-performance servers that are required. We make much better use of that technology. To the users, everything is still at their fingertips. So they've got instantaneous switching. They've got support for tablets, jog wheels, hard disk drives, whatever it may be, as if all those devices were still in the room, but they're now in a data center or even spread across campus. This helps restrict physical access to the servers, and via the use of KVM logon technologies and authentication, restrict access to the servers and applications, other hardware interfaces. I'm not going to go through all of these. You can read the slides for yourselves, but there's a lot of different uses for KVM where it can actually help reduce overall costs, improving connectivity. So if we have a look at some of the direct connect KVM solutions, we have typically a central matrix switch somewhere in the building to which our category X or our fiber cable comes out from, goes to the servers, and it goes to the users' desktops. We use transmitters and receivers to connect to the central matrix switch, and we use proprietary protocols which have advantages that they can be faster and use less bandwidth, whilst at the same time providing a reasonably scalable solution, but it's probably less scalable than an IP-based solution. We can also provide flexible I/O, so a matrix switch of 16 ports, any of those ports can be an input, or any of those ports can be an output, any mixture thereof. We've got a lot of options for redundancy. There's ways of duplicating switches, duplicating links, and basically providing no single points of failure within a network. So looking at a typical non-IP based product, a typical direct connect product, we can see here one example of the DKM. It's a 160 port switch in the middle of a load of transmitters and a load of receivers running a proprietary protocol. Instantaneous access to hundreds of endpoints, copper or fiber, 2K, 4K support, audio, USB, RS-232, RS-422, USB 3, and a lot of other interfaces supported directly through KM. It's a fantastic system. We've got a lot of these out there in the marketplace. It's got excellent redundancy options and very easy to manage internally. To make it more powerful, we can now combine this with Emerald, Bugzilla and Control Bridge that we'll get onto shortly, and provide an overall unified solution. So here we have an example where we take output from IP-based system and bring it into the DKM, so that now a non-IP based system is connected to an IP based system. And we can do this both ways round to provide access so that the IP receivers can jump onto any non-IP transmitter. So combining DKM and Emerald, you've got the advantages now, both technology types merged together. So you've got virtual desktop infrastructure, virtual machine support, great flexibility and scalability, single point of management, and you can observe the existing user workflows, improve them as well. We can connect to multiple direct connect systems in different locations via IP. Some of the other products we've got, we have the DCX 3000 and 1000 range. These are of limited port count, 10 or 30 ports, digital only systems. And one of the great things with the DCX is that it provides a global overview of each individual server. We can see on this picture on the right hand side, we're actually displaying the outputs of 8 servers on the screen. The user can click into any one of those segments and bring that particular server full screen. So this is a great tool for managing servers in a very limited environment where you're not going to have more than 30 endpoints. It's completely digital throughout the system. It's very affordable. Got quite a few of these on site with various prestigious customers. It just provides them with an easy multi-view interface. Uncompressed video, lossless technology. We're not dropping pixels, frames, very low latency. Now within this, we can add on other products such as the Freedom, offering this glide and switch capability to provide what extended desktop feel to separate computers that have no inherent network connection between them. It allows 4 or even 8 machines to just look as if and feel as if they're just one single machine. As I touched on earlier, the multi-viewers allowing us to make much better use of these large format displays we've all become used to by putting multiple images from multiple sources from screen upwards. So a quick look at Bugzilla. This is our unified management tool. Basically, we can control user access. So we are involved in the user authentication. The user connects onto any individual device. Commands to control the network switches, bring up or tear down cast links. More usefully, we can also interactively diagnose problems and even spot problems before they occur. And we'll have a look at the management screen in a second briefly. It makes the upgrade process for KVM solutions much easier because you've got a single point of contact to upgrade a whole KVM network. Integrate with Active Directory, so if a customer is already using AD on site, we can bring in all the authentication that AD is offering and bring that in through via Bugzilla. Here's a couple of screenshots of the dashboard. Basically, you can see a link, a connection to a transmitter, a connection to a receiver, the bandwidth being used, any dropped frames, dropped pixels, any alerts that are generated, any security that are generated, peaks and troughs of usage through the day, any instances of dropped frames that happen in groups through the day, tell which users are connected onto which systems, how long they've been on there, what the authorization was, whether it came through Active Directory or whether it came from just itself. A lot of information presented on a very easy to read screen, lots of graphical feedback to the system managers. It will help give alerts as to when your utilization is getting dangerously close to being overused and therefore frames being dropped. Here we can see we've used pretty much the same slide as before, but now Bogzilla is introduced into the network. And this is now allowing us to not just manage the IP side, our Emerald, but also the DKM side, which is Direct Connect. As we look forward in KVM, we're trying to provide users with a much more user-friendly environment. Typically, the amount of information a user needs to manage has gone up tenfold, and they need to have the ability to switch through all these different systems with ease, to understand at a second's notice system is connected onto which screen, the different roles and profiles of different users throughout the system. So we need provide ways of making this management much easier for customers. Automated notifications for handling alarms and single entry points for applications or CPU failures. It can eliminate any single point of failure in the network. Also provide intuitive switching to redundant CPUs and applications in cases of emergency or where things have gone wrong. One of the great ways of managing a KVM solution now is by using a control bridge touchscreen system. But it goes beyond managing KVM. Using the I/O controllers, we can connect pretty much to any device on the planet, whether it be Ethernet, serial, infrared, digital I/O, relays, whatever it may be. So this allows us to control lighting, building management systems, heating, KVM solution, projectors, AV as a whole. Everything can come under a single touchscreen interface. And they're very intuitive. It makes perfect sense for users to be able to go up and tap a source, tap a screen, and expect to see that source on that screen. And it's pretty much instantaneous switching. Very low latency. We're down in the milliseconds. To improve operational functioning, it helps improve the productivity for a user. It helps them spend less time in trying to move between systems, and the users just have a good flow to the processes they need to employ in their job. Screen design is completely programmable. It's a color display. We can put buttons, sliders, all kinds of things on the screens, whatever customers require. The interface custom built from the ground up, but it makes such a good use of this UI interface. It's so intuitive for customers to use. They can see at a second's notice what can be connected to where, and they can just go ahead and do things. Temperature down in a room, turn the lights off, bring a screen down, turn the projector on, and all of this can happen with the touch of one single button. We have support for pretty much all KVM user modes. Mobile app used with the system, and we've been integrating this with DKM and Emerald for a number of years now. So this isn't actually that new to us. What is new is the way that we can employ it even further moving forward to bring in all these BMS systems and external systems. So we use control processors. We've got multiple IOs on them. I'm not going to dwell too much on this, but basically the idea is it doesn't matter whether it's an infrared control, relay, or a serial. It comes in to one of a number of control processors. All these control processors come into a single control bridge interface. You can have as many touchscreens as you like. You can have different layouts and different touchscreens. but it just makes life much easier for the customers, much more intuitive. Switching around systems becomes very instinctive, and it doesn't matter what those systems are. More meat on that. You can use this for controlling your video walls, your KVM matrix solutions, your AV matrix solutions, any video encoding that goes on site. A lot of customers may be providing video over IP solutions. This would be a great thing for hotels, for example, providing IP to the hotel rooms. Encoders can be controlled from Control Bridge. You've got great data visualization. Digital signage alerts can be encompassed, and alarm responses can be all encompassed into this one single interface. So here we've got an example where we've got a KVM matrix solution coming in as a selection of operators sitting at a desk, and some of this video from the local sources is going out into encoders, some of it's going out into video wall processors, maybe a remote video wall on another site. There's digital signage going on, and all of this is being controlled through a single Control Bridge control panel, or a number of panels, depending on what the customer wants. Right, there was a lot to get through there, and I suspect that we're going to have a few questions. So I'd like to thank you very much for your attention so far, and see if there are any questions, guys.
Thank you, Brian. Yeah, we do actually have a few questions. First one, will Emerald be able to support faster USB speeds? Could be USB 3 or USB-C in future models?
Unlikely for the foreseeable future, because both USB 3 and USB-C, we're looking at 5 gig of bandwidth being required. Now, utilizing about 9 gig to 10 gig of IP bandwidth for the video. So the majority of all of our bandwidth is going on the video, and we're then leaving roughly, it's a little bit less than a gig for all the USB stuff, the audio, the serial, and the other kind of interfaces. However, having said that, we're using USB from say a source device on your desktop, such as a disk drive, going back to the computer. This is something that we are trying to look at, because we're dragging the 10 gig of video server to the user. That doesn't affect the bandwidth going back from the user to the server. So that in theory, we would be able to support it. But at this moment in time, focus on the roadmap, bringing in additional features such as the glide and switch, such as multi-stream technology, and all these other applications that the customers have already requested that we get on the roadmap. So they're on there, and a lot of these are going to be due for release in November, and then the next round of releases in March. Now, once we've got that part of the roadmap out of the way, we can begin to look at whether we can actually support USB-C or USB 3 or 3.1 at full speed, 5 gig, but it's probably going to only be going back in one direction. We can do this currently using DKM. We can provide USB 3 connectivity through a switch, and obviously managing that switch we can do via Emerald or via Control Bridge, or a mixture of the two. But that's currently the way the land lies.
Okay, thanks, Brian. So far, final question for the day is use Control Bridge in my meeting room. Short answer.
Control Bridge is so powerful it can control anything. So as I say, there's absolutely no problems putting it in a meeting room, and at the touch of one button on Control Bridge, you can dim the lights, turn on the air conditioning, bring a motorized screen down from the ceiling, switch on the projector, change the projector video interface to be a particular interface, say HDMI 3 or something, turn the audio system on. What else you want to do? We could even use it to turn on a glitter ball in the middle of the room using relay controls. So you can literally do anything and control anything through Control Bridge. So short answer, yes. Long answer, hell yes.
Okay, thank you very much, Brian. I think that concludes the webinar for today. We would like to thank everyone for participating, and if any questions or you need help with anything, feel free to reach out to either me or Casper. We will leave the contact details for a few minutes. Thank you so much for participating.
Everybody.